This is one of our additional dynamics questions because students asked me to solve a few questions, so I'm going to put those questions into this video. So the first one is going to be about the skydiver. This is why you see this picture. So let's look at the question that you have in your lessons related to the skydiver. In this question, they say that a skydiver is jumping out of a plane. During the first few seconds of one jump, the parachute is unopened, and the magnitude of the air resistance acting on the skydiver is 250 newtons. So that information is given. And then the acceleration of the skydiver during this time is 5.96 meters per second squared. And they ask you to calculate and the mass of the skydiver. So I'm going to look at the forces acting on the skydiver. You have the force of gravity, so that is mg. And then you have the force of the air resistance. So I'm just going to call it F, the air resistance. So you have the air resistance is up and the force of gravity is down, so that is negative, and that is equal to negative ma because acceleration is down. So acceleration of the skydiver is going to be down, and I chose my positive direction to be up. I use Newton's second law to write this equation. So for the Newton's second law, we have the net force, this is your net force, is equal to mass times acceleration. Back to our problem. So they say that the skydiver has the magnitude of the air resistance force acting on him is, or her, 250 newtons. So instead of F, I'm going to plug in 250. So this is 250. And then I have minus mg and equals to negative ma. They give you acceleration, so I can plug in that one. And I know acceleration due to gravity is 10. So what I have is 250 equals to, I'm going to factor out m when I move this term to the other side. What I have is g minus a. Then I have 250 equals to mass, and g is 10 minus the acceleration that they give you is 596. So from here I can find out that the mass of the skydiver is equal to 61.88 kilogram. And this is if I choose g to be 10. If I choose g to be not 10 but 9.8, my mass, so for different g, 9.8, my mass would be equal to 65 kilogram. On AP exam, it doesn't matter which one you choose for acceleration due to gravity to be 10 or 9.8. You can choose either one, and these calculations or the differences in calculations do not count against you as long as you follow the right steps to solve the problem. In the next question, they say a 55 kilogram female bungee jumper fastens one end of the cord made of elastic material to her ankle and the other end to the bridge. Then she jumps off the bridge. As the cord is stretching, it exerts an elastic force directed up on her. Calculate the acceleration at the instant the cord exerts an elastic force of 825 newtons on her. So this information is given. So if I imagine this is the jumper, and at the moment when the force exerted up on her is 825 newtons, so I'm going to call this tension force, and her force of gravity is mg, and the acceleration, I would assume that she's still falling down, so maybe she is still falling down. Acceleration is this way. If I did not plug in my numbers correctly, or I did not choose acceleration in the right direction, I'm going to get acceleration different direction, or I'm going to get a different sign, like a negative sign. Then I will know that I chose my acceleration in the wrong direction. This especially works well with your pulleys when you guess the direction of the masses or objects in the pulley system. If you did not choose the right acceleration, your answer comes with it does not mean that you did not choose the right acceleration. There is acceleration that comes negative as your solution. That means you chose the direction of the acceleration in the wrong direction, but it does not mean you solved the problem wrongly. Okay, so her mass is given. If we plug in the numbers, we have the tension, the net force, is equal to MA. Always start with this problem after your force diagram, free body diagram. So we have tension minus mg and equals to negative MA. And I'm looking for acceleration. So the tension is 825. Mass times g is 550. I'm plugging in g as 10. And equals to the negative mass times the acceleration. So the acceleration is going to be equal to negative 5 meters per second squared. So that means the acceleration is not down, the acceleration is up. The one that I chose was not in the right direction. So the acceleration is actually up. So that means she's slowing down and the cord is keeping her from slowing down. So the acceleration that I should have chosen would be this much, and then this sign would change and give me the positive acceleration. Since I'm already solving the question, I didn't want just to do two questions that were asked about, because I solved these two questions for people when they would come to the classroom and ask questions. I thought I'm going to solve this for everybody. So a crane is used to hoist a load of mass, and the mass is given 500 kilogram. And the load is suspended by the cable from a hook of mass is 50 kilogram. As shown in the diagram, the load is lifted upward at a constant acceleration of 2 meters per second squared. So there is acceleration at 2 meters per second squared. And determine the tension T1. So this one is T1. So it's pulling this way. So this is T1, and it's this way. So that is T1. Then I have this one is mg, the force acting. Also, the hook has mass, so there is still the force mg. So maybe let's do, this one is big M g, and this one is little m g. And then I have tension 2. And so determine the tension T1 in the lower cable and the tension T2 in the upper cable, as the hook and the load are accelerating upward at the acceleration of 2 meters per second squared. So the hook has does not know anything about what's happening to it, that there is a mass attached to it. So all the hook knows is that it is there, and some mass is acting on it, or some forces acting on it. So the forces acting on the hook are T2 is positive, and then I have mg is negative, and then also there is T1 pulling it down, and that is equal to ma. And also the mass has no clue what's happening to it. All it knows is that there is a force T1 pulling it up, and at the same time the mg is pulling it down, and it's accelerating up. So I could solve this equation for T1. So T1 is equal to mg plus ma. And then I'm going to take this and plug it in instead of T1. So I'm going to have T2 minus mg. And then this minus, when I subtract each one of these terms that I have for T1, I'm going to change each sign because there's going to be a negative minus the whole thing. So I'm going to have minus mg, and again minus ma, and equals to ma. And they ask you the tension, they give you the acceleration. So I know acceleration, I don't know the tension, so I have to solve for T2. So T2 is equal to, I have mg plus mg, and then I have ma plus ma. So tension 2 is equal to, or actually I could find T1 from the beginning because everything was given, so I could find T1 right from the beginning. So plugging in mg and mg. So I have 500 for the hook, and then I have 5,000 for the mass, and then I have 2 times 50, 2 times 500 is 1,000, and then I have 2 times 50, which is 100. So that gives me 6,600, so 6.6 kilonewtons. So that's the force in T2. And for the force in T1, I didn't need much, so I could just solve it, the whole thing right here. I have mg, which is 5,000. And I have ma, which is 1,000. So that gives me 6 kilonewtons, or 6,000 newtons. So I'm just going to write kilonewtons. So that is T1. And in this question, you're given two masses. M1 is 0.5 kilogram or 500 gram, and the M2 is 200 gram or 0.2 kilogram that start out at rest. As one mass falls, the other mass rises. What is the time required in seconds for the mass that starts out above the ground to fall 60 centimeters to the table? So I'm going to call the one on the left M1, and then the one on the right is M2. So for M1, I have M1G, and then tension, it's the same tension for both of them, and then I have M2G and tension. And the acceleration is going to be up for this one, and acceleration is going to go down for that one, and it's the same acceleration, so it should be the same length. So I have the equations. Net force is equal to ma. So for the first one, I have tension minus m1g equals to acceleration is down, negative m1a. And then for the second, I have tension minus m2g, and acceleration is positive, so that's m2a. And I can do substitution or elimination method to solve this system of equations, and I'm going to use elimination. I'm going to subtract one from another, and when I subtract, I'm going to subtract it up. So I'm going to say this tension minus this tension cancels, and then I have m2g minus, so that will give me plus. So I have negative m2g, and then the m1g is going to be positive, m1g. And then on the other side, when I subtract m2a minus and minus, m1a will give me positive. So I'm going to have equals to m1a plus m2a. And then if I solve for a, I will have a is equal to, I'm going to take g out from both of those, so I have m1 minus m2, and then I have m1 plus m2. So g is 10, and m1 is 0.5 kilogram, and minus 0.2 kilogram, that gives me 0.3 kilogram. And if I add them, that's 0.7 kilogram. So it is 3 divided by 0.7. That gives me 4.29 meters per second squared. And the question is, what is the time required in seconds for the mass that starts out above the ground to fall 60 centimeters? So my acceleration is given, and the distance is given. I can find the final velocity. So I can do the final velocity is equal to, for acceleration and the distance, is the square root of 2 acceleration that I found, the distance, plus initial velocity squared, which is 0. So my final velocity is going to be equal to 227 meters per second. And if I want to find the time, I can do the distance formula because the distance it travels is given, or I can do I can use the acceleration formula. I'm going to use acceleration formula. Acceleration is the change of the velocity divided by the time. So they ask me how long it takes. It's the time, which is the change of the velocity over the acceleration. The initial velocity is 0, the final velocity is 227, and acceleration is 429. So that will give me 0.53 seconds. And that was all I wanted to cover you in this video, additional just because the students asked me to solve some questions that are in this video. So thank you for watching, and I'll see you in the next video.